In this video, we're going to try and figure out the function for which this infinite series represents. So the first step is try and look for patterns. So here you've got to the power of 3, to the power of 3, to the power of 5, to the power of 5, 7, 7. So in your mind, visualize something like this: 5x to the power of n. And then here 3 matches up with this 3, this 5 matches up with this 5, and so on. So in your mind, picture this. It's got to be, because this has to match up with this, because this has to match up with this, and then here you've got minus, plus, minus, plus. So you know you're going to need an alternating component to this. So it could be n, or it could be n plus 1. We just don't know at this stage. And then also here you're just looking at odd numbers: 3, 5, 7, 9. So if you're thinking about even numbers, then think about this. Because we're thinking about odd numbers, we've got to think about 2n plus 1. So this has to be, well, we only care about odd numbers, so 2n plus 1, and then change this to 2n plus 1, because we only care about odd numbers, factorial. And then this here, you just got to think about it. Well, to generate, once you get to this stage here, then look for something of this form. Maybe, well, you're looking for something where you have 2n, where you have odd numbers, factorial. Well, odd numbers factorial, this is an even number factorial. This is just over n. This is an odd over odd, an odd number. Well, you should be looking at this. Because here you've got 2n plus 1. I don't know if you can see it, but here you've got 2n plus 1. You've got the alternating component, and then you've got to the power of an odd number. Here we've got to the power of an odd number. Well, from here, jump to here. That will then generate. That will then give you this. Well, if you look at sign here, this matches up with this. But here's a problem. When n equals 0, if you put this into here, it will generate. Hang on. When n equals 0, put it into here. This thing here will be 0 plus 1, so that's to the power of 1. That's to the power of 1. So that when n equals 0, it will be 5x to the power of 1 over this times 0 will be 0 plus 1 factorial. It's going to be 1, and then this is going to be 1. So the first term will be 5. When n equals 1, when you put 1, when n equals 1, when you put 1 into here, and so on, the second term will be this. When n equals 2, it will be this. When n equals 3, it will be this, and so on. But here's a problem. This here is our original series. This is what we're trying to investigate. But by us looking at this, it generated this series. The two are not the same. The two are very similar, but they're not the same. So here this matches up with this. This matches up with this. This matches up with this. Remember, this is a series that we're trying to investigate. This was what we generated. You see, we don't want this, and we want this. So the thing is, this is a series that we're trying to investigate. We are trying to investigate this series. This is something that we generated. Well, this is a series that we're trying to investigate. Rewrite this as this. Rewrite it as 1, and then take away 5x, and then this is what we generated. So this is the series which we're trying to investigate. This is what we generated. So this is what we're trying to investigate. Rewrite what we're trying to investigate as this. Rewrite it as this. Now this we know. This we know was our summation up here. Okay. So this summation here generated this. So now this whole thing here. So this is what we're trying to investigate. Rewrite this as this, and then don't forget this whole thing here. This whole thing here was summation negative 1 to the power of n, and then what was it? X to the power of 2n plus 5x to the power, and then over what was it? 2m plus 1 factorial. You see, this is this whole thing here, and this is actually sine 5x. So this whole thing here is actually sine 5x, and then this bit here is this bit here. Okay, so overall, the series which we're trying to investigate, this series here represents this here. Okay.